Okay, so we're now going on to limits at infinity. And what we need to take note of is that limits at infinity is based on one main rule that says the limit as x approaches positive or negative infinity of 1 over x is equal to 0. So our aim in limits at infinity questions is to be able to identify this format 1 over x and know that when we are going to substitute positive or negative infinity, it is going to give us 0. Now, let's understand why this makes sense. So we are first going to look at a few x values and see what happens to 1 over x. So let's start off with 1. We'll go on to 2, then 3. Let's just skip a few values. Let's try something bigger, for example 20. Skip a few more and try something even bigger, let's say 1,000. Now we are going to take these x values and substitute in place for 1 over x. So we're first going to have 1 over 1, which is equal to 1. Then 1 over 2, which is equal to 0,5. 1 over 3, which is 0,33. 1 over 20, which is 0,05. And 1 over 1,000, which is going to be 0,001. Now, let's identify a pattern. On the left-hand side, we substituted x values that were increasing each time. And notice what's happening on the right-hand side with 1 over x. As those x values got bigger, the values of 1 over x decreased each time, where eventually they are getting closer and closer to 0. So this tells us that whatever value we substitute for x in 1 over x, as long as that value gets bigger, the value of 1 over x itself will get smaller where it approaches 0. So that makes sense for positive infinity. As x approaches positive infinity, 1 over x will approach 0. So it's safe for us to say that if we substitute infinity itself in place of x, 1 over infinity. Since infinity is such a large value, we don't exactly know what value it is, but it's such a large number that 1 divided by this infinite amount is definitely going to equal to 0. Now, similarly, we can apply the same rule for negative infinity. So let's make use of the same values that we have, but instead they are now going to be negative values. So we'll be substituting the negatives of those values, and those are going to yield negative answers as well. But even though we are now substituting negative values, as the x values are approaching negative infinity, 1 over x is still approaching 0. So regardless of whether we're approaching positive infinity or negative infinity, this rule still stands. 1 over x will equal to 0. Okay, so that's just to help you understand why this rule makes sense. We are now going to look at a few examples where we apply this and see exactly how we're going to make use of this rule. So let's call this example 1. Say we have the limit as x approaches positive infinity of x to the power 4 plus x cubed all over 12x cubed plus 128. Now, in the previous section, where we learned about limits approaching some constant c, we learned that our first step is to factorize. However, for limits at infinity, that first step changes. We no longer factorize in our first step, but rather we look at our denominator and we try to identify the term that has the highest exponent of x. So if we look at our denominator, x with the highest exponent is x cubed. That is your first step. You are trying to identify the term with the highest exponent of x, and it has to come from the denominator. Now, once you've identified that term, that brings us to the next part of the first step where we now make use of that term. Okay, so we are going to divide throughout by this term. So let's make a note of that. Divide throughout by the highest exponent of x. Okay, divide throughout by the highest exponent of x. Now, that tells us that every single term that we have in this question is going to be divided by x cubed. So in our numerator, both x to the power 4 as well as x cubed will be divided by x cubed. In the denominator as well, both terms will be divided by x cubed. So that is our first step. Once we identify the term with the highest exponent of x from the denominator, we divide throughout by that term. So part of simplifying, we are still going to cancel out. So we notice that the first term can be simplified. So we have the limit as x approaches positive infinity. In our first term, we can apply laws of exponents. We have x to the power 4 over x cubed. That is just going to be x. In our second term, we've got x cubed over x cubed. Those two can cancel out with each other. We are just left with 1. In the denominator, we've got 12x cubed over x cubed. Those two can cancel out with each other as well. We are just left with 12. And in the next term of the denominator, we have 128 over x cubed. Now, there isn't anything that can be cancelled out there, so that is going to stay as is. 128 over x cubed. Now, once you have cancelled out your common terms, or rather simplified, there may be some terms that are left that are in this format of 1 over x. In this case, 128 over x cubed is of the format 1 over x. So it's actually 1 over x with a positive exponent. It doesn't have to just be 1 over x. It could be 1 over x squared, 1 over x cubed. In this case, we have 128 over x cubed. So we are now going to make use of this limit. And we immediately know that when we take this infinity and substitute in place of x, 128 over x cubed is going to give us 0. So it is not necessary for you to show the step where you actually substitute the infinity, but for the sake of us understanding exactly what goes on, I'm just going to show it at the moment. Now remember that you are making use of the limit, so you no longer need to write down the lim on the left hand side. We are now taking this infinity and substituting wherever we have x. Okay, so that is going to give us infinity plus 1 all over 12 plus. And when we substitute infinity in place of x cubed, we know that 1 over x approaches 0. So this term is just going to be 0 immediately. You can show 1 over 28 over infinity cubed, but I'm just going to make use of the rule straight away and let that equal to 0. Now, if we simplify this, in our numerator we have infinity plus 1. Now, you need to understand that adding 1 onto infinity still remains as infinity. The same thing applies when we take infinity and we multiply it by a certain value or we divide it by a certain value. Infinity will not change. So we have infinity plus 1, which is still infinity, and infinity divided by 12. Infinity divided by 12 is still infinity. So the final answer for this question is infinity. Let's just quickly recap what we have done and complete our steps as well. So the first step is for us to identify the highest term or x with the highest exponent from the denominator. Once we've identified that, we are going to divide throughout by the highest exponent of x. The next step is for us to simplify, and once we simplify, we are going to have some terms that cancel out. After you simplify, any term that is of the format 1 over x will be replaced with 0 once we make use of the limit. So divide throughout by the highest exponent of x, simplify, and we know that we make use of the rule.